Look at the device you're listening to this on right now. Just hold it in your hand for a second.
Yeah, feel the weight of it.
It feels solid, doesn't it? I mean, it has mass. It takes up space.
Right, it's tangible.
But what if I told you that the device you are holding doesn't actually exist as a solid object?
Which sounds completely absurd at first.
It does. But what if I told you that mathematically and physically, everything you consider matter is really just a localized whirlpool of frozen light?
Suspended a cosmic pressurized ocean.
Yeah.
It's wild.
It is the ultimate illusion of human perception, really. We are built to interact with the universe at a macroscopic scale, so our brains basically just invent the concept of solid stuff.
Because we have to, right, to survive.
Exactly. But when you look at the fundamental architecture of reality, that solidity completely vanishes.
So usually when we talk about the fundamental laws of physics on this show, there's this underlying expectation of abstract geometry,
Oh, absolutely. The whole space-time fabric idea. Right. We're taught to think of gravity and mass like a magic trick on a stage. The magician tells us that mass bends the very fabric of space-time.
We all know the classic analogy, right?
Yeah.
The heavy bowling ball sitting on a trampoline.
Yes. Warping the fabric, and the planets just roll along that curved dip. The stage itself bends.
Right, and we see the effect. The physicist points at the chalkboard and says, there it is, space-time is curving.
Which has been the dominant paradigm for over a century now. I mean, it's elegant, it's deeply mathematical.
And to be fair, it has successfully predicted many observable phenomena.
Yeah, and it's comforting. We like having a visual, even if it's this completely abstract geometric concept.
Sure.
But today, for this deep dive, we are throwing the bowling ball and the trampoline entirely out the window.
They're gone.
We're looking at a stack of incredibly dense theoretical papers, mathematical proofs, and historical data that outline a unified field theory called the Redefined Mass framework.
Developed by Vrbovsky-Banić and Banić.
Exactly. And our mission for this deep dive is to fundamentally rewrite the rules of reality for you. We are not going to bend the stage anymore.
No, we are going to look under the stage.
Right. We're going to examine the trapdoors, the fluid mechanics, the actual physical gears of the universe that make the magic trick happen.
The premise here is a complete paradigm shift from abstract geometry to applied electrodynamics.
Right.
And what is so fascinating about the source material is that this framework doesn't just, tweak standard models.
Or add another hypothetical dimension to string theory.
Right, exactly. It deconstructs the very nature of matter. It proposes that mass is not a primitive, inherent property of a particle.
Okay, so what is it?
Mass is a dynamic electromagnetic back reaction happening inside a Bose-Einstein condensate, basically a superfluid vacuum.
Okay, before we dive into the math, and let me warn you, the papers go into extensively, I want to clarify this axiomatic shift.
Sure.
Standard relativity tells us space and time are this woven fabric, space-time. So if the redefined mass framework replaces that, what are we left with? If Einstein's stage is gone, what kind of room are we standing in?
We are standing in a perfectly flat room.
Flat.
Perfectly flat. The authors operate on a strict classical ontological principle. Space is a flat, three-dimensional Euclidean void. It has no curvature. It literally cannot bend.
Okay, and time?
Time, similarly, is an absolute universal parameter. It ticks at the exact same rate everywhere in the universe. There is no space-time fabric at all.
I'm going to stop you right there, because if space is flat and time is just a universal ticking clock, how do we explain everything we've measured for the last 100 years?
That's the big question.
Right, because we know clocks run slower on GPS satellites. We know light bends around galaxies. If the stage isn't bending, are all those measurements just wrong?
No, the measurements are completely accurate. What is flawed, according to this framework, is our geometric interpretation of why those measurements occur.
Yeah, explain that.
Well, when an anomaly pops up in standard physics, the tendency is to bend the coordinate system. We say length contracted or time dilated or space curved just to force the math to fit the observation.
Right. We changed the ruler.
Exactly. But the redefined mass model says that all of these relativistic and quantum effects are actually physical, mechanical alterations to the electromagnetic boundaries of matter.
And the surrounding vacuum fluid.
Right. The clock physically slows down because of fluid drag, not because the dimension of time itself stretched.
Wow. Okay, so we're replacing geometry with fluid dynamics. So if space is this 3D void, it's not actually empty.
Right at all.
Because the sources spend an enormous amount of time detailing this subquantum vacuum.
Right.
And I think the average person assumes the vacuum of space is just, Nothing. Empty blackness.
And that is the very first major illusion we have to break today. The vacuum of space is one of the most incredibly dense, highly pressurized environments imaginable.
It's not a void.
No, it is a trapped gas of virtual bosons. Specifically, virtual photons that are constantly popping in and out of existence.
And the sources go incredibly deep into the quantum statistical mechanics here. They talk about the density of states, denoted as G of E, and the thermal wavelength of this quantum gas.
Right, the math gets heavy.
Yeah. So for the listener who hasn't taken advanced thermodynamics lately, how do we visualize a gas made of virtual light?
Think about a regular gas, like the air in the room with you right now. In classical physics, you measure the energy of that gas by summing up all the discrete, individual bouncing molecules.
Right, like tiny billiard balls.
Exactly. But at the macroscopic scale of the universe, the subquantum vacuum operates differently. The thermal wavelength of these virtual particles is so infinitesimally small compared to any macroscopic box you could put them in.
Like incredibly tiny.
So tiny that the sum over quantum states stops being a count of discrete steps and becomes a continuous mathematical integral. This allows Vrbovsky-Banić to treat the vacuum of space as a purely quantum gas with a massive density of states.
And when we say a gas of light, a natural question is, what is the temperature of that gas? Because the number the papers arrive at is staggering.
It really is. The intrinsic energy density of this subquantum vacuum translates to an equivalent vacuum temperature of approximately 4.58 times 10 to the 14th Kelvin.
Wait, 458 trillion Kelvin.
Trillion, yes.
That is thousands of times hotter than the core of our sun. How are we not instantly incinerated just sitting here?
Because it is a virtual subquantum baseline energy. It's the background zero-point energy of the universe.
Oh, I see.
Right? We don't feel it as ambient heat because everything, including our own bodies, is constructed from this exact same baseline energy scale.
We're made of the heat.
Exactly. But what is critical about that specific number, that 458 trillion Kelvin, is that it perfectly matches the energy scales of what physicists call the electroweak unification epoch in the early universe.
Okay, why does that matter?
Because at this extreme baseline temperature, the virtual photons in the vacuum undergo a massive thermodynamic phase transition.
A phase transition, like water freezing into ice.
Precisely. They collapse into a single, coherent macroscopic quantum state. The entire universe is filled with a macroscopic Bose-Einstein condensate, a BEC superfluid.
Hold on. If space is filled with an unimaginably dense superfluid, shouldn't the Earth eventually slow down in its orbit because of friction?
You'd think so, right?
Yeah, like putting a car in neutral on the highway, we should be dragging against this fluid.
That is the beauty of a Bose-Einstein condensate. When a fluid enters a perfect superfluid state, its viscosity drops exactly to zero.
Zero viscosity.
Zero. There is no kinetic friction. The Earth can coast through the subquantum vacuum forever without losing any orbital momentum to drag.
Wow.
It's just like liquid helium creeping up the sides of a beaker in a laboratory without any resistance.
Okay, so we have a perfectly frictionless, perfectly dense ocean of frozen light. Now, how does a particle, a piece of matter, actually exist inside this ocean?
Well, the framework points to an electrodynamic foundation, starting with wave-particle duality.
Right, wave-particle duality. I feel like everyone has heard that term. It's the idea that a photon or an electron acts like a particle sometimes and wave other times.
Yes.
But standard physics always explains it as this spooky, unexplained probability thing. Like it doesn't decide what it is until we look at it.
Right. Standard physics accepts duality as a statistical probability. It relies on the Copenhagen interpretation, which says the particle exists as a mathematical waveform of potential states.
But redefined mass doesn't buy that.
Not at all. It rejects that mysticism entirely. It gives wave-particle duality a concrete, physical, spatial structure. There is no probability.
So what actually is a particle then?
The particle aspect is simply a physical, subatomic, spherical charge boundary shell. It's a localized, sharp boundary in the superfluid.
Okay, a boundary.
And the wave aspect is the continuous, localized, electrostatic, self-energy polarization cloud that surrounds and literally constructs that shell.
Wait, so they aren't two different things?
No. They are a singular, inseparable physical structure. You cannot have the shell without the cloud of polarized vacuum surrounding it.
I need to visualize this boundary. The papers mention that when this BEC condensate forms, it exhibits perfect diamagnetism due to the vacuum Meissner effect.
Yes, the Meissner effect is crucial here.
Now, the Meissner effect is usually something we see in supercooled superconductors, right? You cool a magnet down, and it suddenly repels magnetic fields and just, like, floats in midair.
Exactly. And inside the subquantum boundary of a particle, the relative permeability of the vacuum, which is its ability to support a magnetic field, drops to nearly zero.
Oh, wow.
The vacuum-Meissner effect actively expels magnetic field lines from the core. This physical expulsion creates a sharp, impenetrable physical boundary for the mass shell.
So the particle isn't a tiny billiard ball of solid matter, it's an empty bubble in the fluid,
Yes,
maintained because the inside of the bubble refuses to let magnetic fields enter.
that's it. And the authors actually propose verifiable experiments for this. They state that we can verify this sharp subatomic boundary via Guth-Henshin polarization shifts and relativistic transition radiation.
For the listener, what is Guth-Henshin shift in simple terms?
Sure. When light reflects off a sharp boundary between two different optical mediums, like light bouncing off the surface of a glass of water, the beam actually shifts slightly along the surface before reflecting back.
Like a little skid.
Exactly. A tiny, measurable displacement. The authors are predicting that if we scatter high-energy waves off an electron, we will observe this exact same optical shift.
Which would prove
That the electron is literally a sharp, refractive boundary in the vacuum fluid, not a solid point mass.
that is brilliant. But I have to ask the obvious question here.
Go for it.
If mass is just an empty bubble, a boundary of trapped light surrounded by a polarized cloud in a frictionless superfluid, why does a rock feel so heavy to you when you try to lift it?
Right, the problem of inertia.
Yeah. Where does inertia come from? Because standard physics says mass just inherently has inertia. A big rock has a lot of mass, therefore it's hard to push.
Which is really just a circular definition. It doesn't explain the mechanism at all.
No, it doesn't.
But the redefined mass model answers this beautifully using pure electrodynamics. Inertia is not an intrinsic primitive property of matter. Imagine a quark inside an atom of that rock.
Okay, I'm picturing it.
When you push the rock, you are accelerating that charged quark through the vacuum.
And whenever a charge moves, it generates a magnetic field. That's basic high school physics.
Right. But creating that magnetic field requires energy. That energy consumption creates a physical electrodynamic resistance to the acceleration.
It pushes back.
Think of Lanz's law in electromagnetism. When you drop a magnet through a copper tube, the changing magnetic field induces currents in the copper that create their own opposing magnetic field, slowing the magnet's fall.
Oh, it creates a drag.
Exactly. Inertia is literally the self-inductive back reaction of a particle's self-generated magnetic field resisting any change in its velocity.
So when I push a broken down car, the reason my muscles are straining isn't because the car's full of solid stuff.
Nope.
It's because I am forcing trillions of tiny charge boundaries to generate magnetic fields all at once, and the energy required to spin up those fields pushes back against my hands.
You are fighting electromagnetic drag. The energy you transfer from your muscles to the car to give it momentum is physically stored in the surrounding vacuum.
Stored in the vacuum.
Yes, stored as the energy-contained magnetic fields generated by the moving quarks.
That completely reframes reality, and the papers tie this directly to the Higgs field, don't they?
They do, in a very elegant way.
Because we always hear that the Higgs field gives matter its mass. But usually it's described as this mathematical scalar field.
Yes, standard physics relies on the Higgs field as a scalar field that mathematically couples to particles to bestow mass. But it completely fails to explain the spatial mechanism.
How so?
Well, how does a dimensionless mathematical field create a vector back reaction force, a directional force that specifically opposes your hand when you push that car? A math equation doesn't push back.
But a pressurized fluid does.
Exactly. The redefined mass model proves that the Higgs field is not an abstract scalar field. It is actually the coherent electromagnetic vacuum polarization cloud surrounding the particle's physical boundary.
So when you pick up a rock,
You are moving trillions of these localized boundaries through a highly tensioned, contiguous superfluid. The solidness and weight you feel is the macroscopic manifestation of this electromagnetic drag.
wow.
The vacuum is perfectly frictionless when you are coasting at a constant speed, but the moment you accelerate, the vacuum polarizes and fights back. You are literally feeling the resistance of the vacuum.
My mind is officially blown. We are just swimming in an ocean of tensioned energy.
We really are.
So now that we have established this new baseline reality, a flat 3D space filled with a BEC superfluid vacuum where mass is just an electromagnetic boundary, The authors take this framework and systematically use it to resolve 22 major mysteries or retrodictions in modern physics.
And they don't just offer philosophical musings, right? They provide the rigorous mathematical derivations for each one.
Starting with anomalies that have baffled physicists for over a century, let's get into the heavy hitters.
Okay, where do we start?
Mystery number 1, the 43 electron anomaly. Before we explain how the fluid vacuum solves this, we need to explain why this was such a nightmare for classical physicists who first discovered this anomaly.
This goes back to the late 19th and early 20th century, way before Einstein's relativity took over. Brilliant physicists like Max Abraham and H.A. Lorentz were trying to build classical models of the electron.
Okay.
They knew the electron had an electric field, and when it moved, it had a magnetic field. They assumed that all of the electron's mass was purely electromagnetic.
Which sounds a lot like what we were talking about today.
It does. They were totally on the right track. But when they tried to calculate the momentum of a moving electron by integrating the energy of its electric and magnetic fields, the math broke down.
How so?
According to the foundational relationship between energy and momentum, they expected the momentum to equal the energy divided by the speed of light squared. But every time they ran the integration, they ended up with a bizarre extra mathematical factor. They kept getting a coefficient of 43.
So the math was basically saying that the electron had more electromagnetic momentum than it should.
Exactly. And even worse, based on pure classical electrodynamics, a sphere of pure negative charge should instantly explode due to its own electrostatic repulsion.
Oh, because like charges repel.
Right. The negative halves of the electron should violently push each other apart. So the math was yielding a 43 momentum factor and predicting the immediate destruction of the particle.
Why couldn't they just measure an electron and see what was holding it together?
Because it's a fundamental particle. You can't put it under a conventional microscope. They had to rely on mathematical models.
So what did they do?
To fix this exploding electron problem, a famous French mathematician named Henri Poincaré had to step in. He realized that pure electromagnetism, as they understood it then, couldn't hold the particle together. So he artificially invented non-electromagnetic cohesive forces.
Which became known as Poincaré stresses.
Exactly. He essentially injected a mathematical rubber band into the equations just to squeeze the electron and cancel out that extra 13 factor.
That sounds like a massive mathematical band-aid, just making up a new force so your equation works.
It absolutely was. And when Einstein introduced special relativity shortly after, the physics community largely abandoned the classical electromagnetic electron model entirely because relativity provided a geometric workaround.
Right.
But the 43 anomaly remained a thorn in the side of theoretical physics.
Until now. So how does the redefined mass framework remove Poincaré's band-aid without using curved spacetime?
By treating the electron not as a solid point mass, but as a dynamic boundary interacting with a fluid. When the spherical charge boundary of an electron moves through the dense vacuum fluid, it faces resistance.
Right.
This resistance physically deforms the boundary. It contracts along the direction of motion.
Wait, you said it deforms. The papers call this the heaviside ellipsoid. Let's picture a football.
Good analogy.
When this perfectly spherical charge moves through the fluid vacuum, the fluid resistance actually squishes it from a perfect sphere into a flattened oval. That flattened shape is the heaviside ellipsoid.
Exactly right. And when you calculate the electromagnetic momentum of this deformed ellipsoid, you still get the external field contributing that troublesome factor of plus 43. But, and this is the stroke of genius in the framework, Vrbovsky and Banić include the internal dynamics of the bubble.
Because it's not a solid billiard ball. It has an inside.
Right. Remember the Meissner effect. The internal core of the electron is a polarized vacuum void. This internal core possesses negative potential energy, denoted in the papers as weepal.
Okay, negative energy inside.
When you integrate the thermal dynamics of this negative internal vacuum core, it contributes a momentum factor of exactly minus 13.
Whew! 4/3 from the outside minus 1/3 from the inside equals 1.
It perfectly cancels out. The total electromagnetic mass equals the relativistic mass without any extra factors. No magical Poincaré stresses are needed.
That is so elegant.
It is. The electron doesn't explode because it is perfectly stabilized by the inward pressure of the external superfluid fighting against the negative potential energy of the internal polarized core.
The fluid holds it together naturally. That is so satisfying. It completely vindicates those early physicists, but adds the missing fluid mechanics.
Exactly.
Which brings us perfectly to mystery number 2. The true origin of E equals mc squared. Now, everyone knows this equation. It's printed on coffee mugs. It's the most famous equation in human history.
Undoubtedly.
And we are universally taught that it is a direct product of Einstein's theory of special relativity, born from the curved geometry of spacetime.
And that is a massive historical misconception. This is actually one of my favorite parts of the source material.
Tell me about it.
If you actually go back and read Einstein's original 1905 paper introducing that concept, the paper was titled, "Does the Inertia of a Body Depend Upon Its Energy Content?" You will find that he didn't rely on Minkowski spacetime geometry at all.
Wait, are you saying Einstein didn't use spacetime for his most famous equation?
Not for the derivation of mass-energy equivalence, no. The geometric spacetime fabric was introduced later by Hermann Minkowski.
Wow, okay.
Einstein's 1905 derivation was based entirely on James Clerk Maxwell's classical electrodynamics. Einstein analyzed a thought experiment involving the radiation pressure of electromagnetic waves being emitted from a moving body.
Okay, tracking with you.
He realized that emitting light changed the kinetic energy of the body, leading to the conclusion that mass and electromagnetic energy are interchangeable.
So Einstein was doing fluid electrodynamics, essentially.
He was working purely with fields. The redefined mass framework simply strips away the later geometric interpretations and carries Einstein's original electrodynamic intuition to its ultimate physical conclusion.
Which is?
If the energy of light possesses inertia, and mass is just trapped light, then the rest mass of all matter must be localized electromagnetic field energy.
The sources show the math for this, and they mention deriving E equals mc squared as a pure Maxwellian identity via the Poynting momentum flux. For the listener who hasn't studied Maxwell, what is a Poynting flux?
The Poynting vector is simply a mathematical tool that describes the directional flow of electromagnetic energy. Imagine a laser beam. The Poynting vector tells you how much energy is flowing in the direction the laser is pointing and how fast.
Okay, makes sense.
The authors take the squished football, the heaviside ellipsoid we just talked about, and they integrate the co-moving Poynting momentum density of that contracted field over all of space.
They add up all the energy flowing through the fluid around the squished particle.
And when they finish the integration, the resulting identity is exactly E equals mc squared.
Incredible.
It is derived not from bending the dimensions of space and time, but strictly from the conservation of electromagnetic momentum in a flat 3D void.
Before we move on to the next set of mysteries, this raises an incredibly important question about where energy actually lives.
Yes, it does.
Because when a particle moves, it generates a magnetic field. When we talk about a baseball flying through the air, standard physics says the baseball possesses kinetic energy as some invisible, abstract property of its speed.
Right.
But in this fluid framework, where is that kinetic energy actually located?
That is the crux of energy partitioning under redefined mass. Standard physics treats kinetic energy as a ghost, an abstract mathematical bookkeeping device. But in this framework, all forms of mechanical energy are physical, localized field energy densities stored in the vacuum.
Stored in the vacuum.
Kinetic energy is not an intrinsic property hiding inside the baseball. Kinetic energy is the coherent magnetic field induction. It is physically, spatially stored as the energy contained in the magnetic fields generated by the moving quarks and electrons inside the baseball interacting with the vacuum.
The energy is in the fluid surrounding the ball, dragging along with it.
Precisely. You are storing energy in the tension of the subquantum vacuum.
Incredible. Okay, if an electron is stabilized by this fluid pressure, what happens when you cram dozens of these fluid bubbles together?
Now we scale up.
Right. That brings us to the nucleus of an atom, where standard physics usually throws its hands up and invents completely new fundamental forces, like the strong nuclear force, just to explain what's going on. Let's explore mysteries 3, 4, and 5 from the framework.
These deal with the heavy hitters of quantum chromodynamics, the study of quarks and the nucleus. First, they tackle the neutron-proton mass split.
Right, a neutron is ever so slightly heavier than a proton by about 1.293 MeV.
Standard physics often chalks this up to the arbitrary masses of the quarks themselves. But redefined mass derives this mass difference physically. Remember, mass is the resistance of the electromagnetic field.
Right.
The proton and neutron are made of different combinations of fractional charges, up and down quarks. The authors mathematically prove that the precise arrangement of fractional charges in a neutron creates a different internal field interference pattern than in a proton.
And that interference changes the mass.
Yes, this specific interference generates a positive vacuum polarization stress that perfectly accounts for that extra 1.293 MeV of inertia.
It's just a different internal fluid tension. And what about color confinement? This is the mystery of why we can never, ever pull a single quark out of a proton.
Right, they are permanently trapped.
You can smash atoms and particle accelerators all day, but you never see a lonely quark pop out.
Because of the thermodynamic boundary pressure of the Higgs vacuum expectation value, or VeV, standard physics says the strong force gets stronger the further you pull quarks apart, like a rubber band snapping them back.
But redefined mass.
It reframes this as external fluid pressure. The vacuum is squeezing the quarks together with an immense, calculable pressure of roughly 57 MeV per cubic femtometer.
A cubic femtometer being incomprehensibly small.
Yes. The surrounding superfluid vacuum is literally crushing the quarks together so tightly that if you try to pull them apart by injecting massive amounts of energy in an accelerator, that energy just polarizes the vacuum and condenses into new pairs of quarks before the original ones can escape the boundary.
You can't break the bubble, you just create new bubbles.
Exactly.
And the proton spin crisis. I remember reading about this. Physicists added up the quantum spins of the 3 quarks inside a proton, and they only accounted for about 30% of the proton's total spin.
The math does add up.
It was like weighing a bag of 3 apples, but the scale says you have 10 apples. Where's the rest of the spin coming from?
Standard physics struggles with this immensely, inventing seas of virtual gluons to explain it. But in a fluid dynamics model, the answer is remarkably intuitive.
Let me guess, the fluid.
The missing spin isn't coming from particles at all. It is the orbital angular momentum carried by the circulating vacuum fluid itself inside the charge boundary.
The fluid inside the bubble is swirling, like a miniature hurricane.
Exactly. The quarks are the eye of the storm, but the hurricane itself, the spinning polarized vacuum, contributes the remaining 70% of the angular momentum.
It makes so much more sense than inventing imaginary particles to balance a ledger. But I want to spend some serious time on this next nuclear anomaly because it is a massive aha moment.
The EMC effect.
Yes, the EMC effect and mass defect. Let's set the stage. When you take protons and neutrons and bind them together to build a heavy nucleus like iron, the total mass of the iron nucleus is actually less than the sum of its individual protons and neutrons. Some of the mass just vanishes.
The famous mass defect.
Right. And in standard physics, we are taught, well, the missing mass converted into binding energy. We use E equals mc squared to calculate it, and we call it a day.
We brush it under the rug.
Exactly, but that doesn't actually explain the spatial mechanics. Where did the inertia go?
That is the failure of abstract geometry. It calculates the energy balance, but fails to provide a physical mechanism for how a particle's resistance to acceleration is literally stripped away just because it's sitting next to another particle.
So how does redefined mass explain the missing mass physically?
Through classical wave field interference, we establish that a nucleon's mass is not a solid core. It is the integrated energy of its self-generated electrostatic and magnetic fields extending outward into the vacuum.
Okay, keeping that in mind.
When you force multiple protons and neutrons into the incredibly tight, bound state of a heavy nucleus, you're placing them in extreme proximity. Their massive electrostatic fields overlap.
Like dropping 2 stones into a pond right next to each other, the ripples crash into one another.
Precisely. And what happens when wave peaks hit wave troughs?
They cancel each other out. Destructive interference.
Yes. This destructive field interference physically reduces the local electrostatic self-energy density in the spaces between the nucleons.
So the fields get weaker between them.
Right. Now remember, what holds the subatomic boundary together? The inward magnetic pressure of the vacuum. But because the internal field energy has been reduced by this destructive interference, the inward pressure on the boundary drops.
The tension loosens.
The tension loosens. And because the inward pressure drops, the subatomic BEC boundary of the nucleon is forced to undergo a slight physical expansion to find a new equilibrium. Its radius literally gets bigger.
The particle swells up because the surrounding fields are canceling each other out.
This is termed boundary relaxation.
Yeah.
Because the particle swells, its charge is distributed over a larger volume, which lowers its self-energy density, which directly lowers its inertial drag against the vacuum.
It physically loses mass because it swelled up.
Exactly.
Okay, wait, is there actual proof that protons get bigger inside heavy atoms?
Absolutely. That is the EMC effect. In 1983, the European muon collaboration at CERN conducted deep inelastic scattering experiments. They shot high-energy muons at iron nuclei and deuterium to map out the momentum of the quarks inside.
And what did they find?
They were shocked to find that the quarks inside the heavy iron nucleus had a significantly different momentum distribution than quarks in free, unbound protons.
The physics community was baffled by that for decades.
Because they treated the proton as a static, unchangeable object. But the EMC data is the direct, empirical physical proof of this boundary relaxation.
The boundary expanded.
The momentum distribution changed because the physical volume of the boundary expanded. The redefined mass framework mathematically derives the exact mass defect curve of the periodic table purely through this geometric field interference.
We are just scaling up these fluid dynamics from single electrons to heavy atoms. It's beautiful. Let's push this into the weirdest territory in physics.
Do it.
Mystery number 20, quantum tunneling and the observer effect, the famous double-slit experiment. For the listener, the classic setup is this. You shoot a single particle, like an electron, at a solid barrier that has two tiny slits in it. Somehow, the single particle seems to go through both slits at the same time, interferes with itself, and hits the detector screen on the back wall in a wave-like interference pattern.
The ultimate paradox of quantum mechanics.
But it gets weirder. If physicists place a detector at the slits just to watch which slit the particle actually goes through, the interference pattern completely disappears.
The wave function collapses.
The particle suddenly acts like a solid bullet, going through only one slit and making a single line on the back wall. Standard physics tells us that the particle exists in a superposition, a wave of infinite probabilities, until human observation collapses the math into a physical reality. Did the universe know we were looking?
Which borders on mysticism. It suggests human consciousness dictates physical reality. The redefined mass framework completely dismantles this by providing a deterministic fluid dynamic resolution.
So no magic.
There is no probability wave, there's only a real physical fluid wave.
Let's start with tunneling. How does a discrete particle, a bubble in the fluid, pass through a solid barrier with two slits?
When a particle encounters a dense solid barrier or an atomic lattice, it is hitting a massive wall of fluctuating electromagnetic fields. Under immense field stress, the particle can momentarily dissolve its geometric mass boundary.
Dissolve it.
The sharp subquantum boundary melts away, dissolving the particle state into pure, coherent field energy.
The bubble pops, but the energy remains intact as a wave.
Yes, it temporarily becomes a pure electrostatic self-energy polarization cloud. This pure wave state can easily navigate the atomic lattice fluid dynamically, rippling through the slits just like a water wave.
Oh, wow.
Once it passes through the barrier and the intense local field stress drops, the wave undergoes a process called vacuum renucleation. The boundary reconstructs itself. The wave condenses back into a particle state on the other side.
That perfectly explains the tunneling and the interference pattern. It literally turned into a wave to get through the wall, then turned back into a particle. But what about the observer effect? Why does the wave pattern disappear just because we turned on a detector?
The universe does not care if a human is looking. It cares about thermodynamics. The framework demystifies observation by treating it for what it actually is, a physical active energy absorption. An active detector is a thermodynamic energy sink.
Okay, explain what a thermodynamic sink is doing to the room.
Imagine a blindfolded swimmer in a calm swimming pool. If you open a massive drain at one end of the pool, water starts rushing toward it.
Right, creating a current.
The swimmer doesn't need to know the drain is open, and you don't need a probability equation to guess where they will end up. The physical hydrodynamic current of the water will inevitably pull the swimmer toward the drain.
The detector is the drain.
Exactly. The vacuum is a contiguous, tensioned, superfluid medium. When you turn on an electronic detector to watch the electron, that machine draws power and interacts with the electromagnetic field of the room. It creates a localized thermodynamic sink in the vacuum fluid.
It creates a vacuum current.
It creates a macroscopic current that preconditions the hydrodynamic phase gradients of the contiguous vacuum before the particle is even emitted from the gun.
Wait, before it's even fired?
Yes. The wave navigating this pre-tensioned, altered vacuum environment responds deterministically to the new pressure gradients. The wave is sucked down a specific path by the vacuum current created by your machine.
So there is no collapse of mathematical probability. Our physical detectors are literally creating a physical vacuum draft that forces the particle down one single path. It is incredibly logical. It's just plumbing.
It is advanced electrohydrodynamics. No mysticism required.
While we are exploring the quantum realm, the sources also mention exotic hadrons like tetraquarks and pentaquarks. Standard physics argues constantly about whether these weird heavy particles are tightly bound fundamental states or just weakly bound molecules of standard protons and neutrons bumping into each other.
The redefined mass framework gives us a beautiful intuitive visual here. Rather than endlessly debating binding energies in abstract color space, it models exotic hadrons geometrically as nested, multi-centered vacuum polarization bags.
Okay, picture time. What does a nested bag look like?
A standard proton is a single localized bag, a single boundary containing 3 quarks where the internal Higgs fluid velocity has dropped to 0. A tetraquark, which has 4 quarks, is not 2 separate protons rubbing against each other.
It's one big thing.
It is a nested shared boundary bag containing 4 distinct centers of charge, all sharing a single contiguous internal vacuum space.
It's like merging soap bubbles. If you blow 2 soap bubbles and they touch, sometimes they don't bounce off. They fuse into one weirdly shaped megabubble with a single shared wall.
That is an excellent analogy. The dynamics of that shared boundary wall dictate the mass, the decay rate, and the stability of the exotic particle.
Let's zoom out. We've been looking at the subatomic scale, looking at bubbles in the fluid. Let's scale up. Part 4. Solar and relativistic anomalies. How do these tiny microscopic boundary fluctuations affect macroscopic bodies like planets and stars?
Oh, they dictate everything.
Let's look at the sun. Standard astrophysics says the sun is just a giant gravity-confined thermonuclear fusion reactor governed by classical magnetohydrodynamics.
And while that model explains the fusion in the core, standard astrophysics utterly fails to explain the coronal heating problem.
Which is a massive paradox. Explain the temperature discrepancy for us.
The visible surface of the sun, the photosphere, is about 5,800 Kelvin. It's hot, but understandable. But as you move further away from the surface, out into the corona, the solar atmosphere, the temperature suddenly spikes to millions of degrees.
Which makes no sense thermodynamically. If the core of the sun is the heat source, the plasma should get colder as it moves further away from the core. It's like stepping 10 feet back from a campfire and suddenly the air is 1,000 times hotter than the fire itself.
Exactly. Standard models try to explain this with complex magnetic reconnection theories, but the math often falls short of generating that much ambient heat.
So how does redefined mass explain the campfire getting hotter?
By proposing that the sun is not just a fusion reactor, it is a macroscopic electrodynamic resonator. The heating isn't coming from standard thermal radiation radiating from the core.
Where's the heat coming from?
It's a thermodynamic result of subatomic boundary relaxation.
Wait, the exact same boundary relaxation we just talked about with the EMC effect in the nucleus. The particles swelling up.
The very same mechanism, but on a stellar scale. Deep inside the high-pressure core of the sun, the local solar electrogravitational vacuum potential is incredibly dense. The gravitational pressure is immense.
Right.
Therefore, the nucleon boundaries of the hydrogen and helium atoms are highly compressed. They are storing a massive amount of localized field energy in their tightly wound boundaries.
They're wound up like springs.
Yes. Now, as massive plumes of plasma are violently ejected from this high-pressure core out into the low-pressure vacuum of the corona, the ambient vacuum density drops rapidly.
The pressure is released, so what happens to the boundaries?
The nucleon boundaries physically relax. They rapidly expand to find equilibrium in the lower pressure environment. Think of a compressed can of air.
When you spray it, it gets cold.
Right, because when you release the pressure, the sudden change in the gas creates a physical temperature change. In the sun, as these trillions of subatomic boundaries unclench and expand, they must shed all that pent-up electromagnetic stress.
And where does it go?
They release that stored field energy directly into the surrounding plasma as violent thermodynamic heat.
The corona is millions of degrees because millions of tons of subatomic particles are simultaneously exhaling. They are literally sweating out the stress of the core.
It is an electrodynamic pressure release valve. The heat is generated locally in the atmosphere by the expanding mass boundaries, not radiated from the surface.
That is just brilliant. Everything is connected. And while we are talking about the sun, we absolutely have to mention neutrinos.
Oh, the ghost particles.
Yes. These are the tiny ghost-like particles that are generated by the sun's fusion, and they fly out, passing right through the Earth, right through our bodies, by the trillions every second. Standard physics says they have a tiny, almost immeasurable mass. and they mysteriously change flavors, morphing from an electron neutrino to a muon neutrino to a tau neutrino while they fly through empty space.
Standard physics struggles with neutrinos because it insists on treating them as fundamental point particles, just like electrons, but without a charge.
But they're not point particles.
Under postulate X3 of the redefined mass framework, neutrinos are not point particles at all. And more importantly, they do not possess a central electrostatic charge shell.
If they don't have a charge shell, what is actually flying through my body right now?
They are topological vacuum defects. They are pure propagating ripples or vortex rings in the superfluid vacuum itself.
Like a smoke ring. If you blow a smoke ring, the ring travels across the room, knocking over a house of cards, but there's no solid object inside the ring. It's just a stable, spinning vortex of the air itself.
Exactly. The neutrino is a vortex ring of the BEC superfluid. Because it lacks a central charge shell, it doesn't generate the massive electromagnetic drag that an electron does.
That explains the tiny mass.
Right? Its mass is incredibly tiny. It's just the minimal hydrodynamic inertia of the vacuum defect moving through the fluid.
And what about the flavor changing? Why does the smoke ring change shape?
Because it's traveling through a fluid with varying pressure gradients. The flavor oscillation is simply the physical oscillation of the defect's topological structure.
So it's wobbling.
As the vortex ring interacts with the fluctuating background vacuum pressure of the solar system during its flight, its shape wobbles. We measure those different wobble states and classify them as different flavors of particles, but it's really just the same smoke ring vibrating.
Okay, let's move from the sun to the planets. Mystery 16, Mercury's precession. This is a big one because the orbit of Mercury wobbling slightly over time, shifting by about 43 arcseconds per century, was the crown jewel of Einstein's general relativity.
It was the proof everyone needed.
Right. Newtonian gravity couldn't explain the wobble, but Einstein proved that the curved spacetime well created by the massive sun caused this exact orbital shift. It is the definitive proof of curved space. If the redefined mass framework uses flat 3D space, how on earth do they solve Mercury without bending the stage?
By calculating what they call orbital mass pulsation. Remember, in this framework, gravity is not a geometric curve.
Okay.
Gravity is a nonlinear electromagnetic correlation between self-energy boundaries in the vacuum. Now look at Mercury's orbit. It is highly elliptical. It is not a perfect circle.
The ray gets very close to the sun and then swings far away.
Which means its distance from the massive solar charge center is constantly changing. Because the distance changes, the local solar electrogravitational vacuum potential that Mercury experiences is constantly fluctuating.
Okay, let me deduce this. Does the sun's gravity physically pull the planet harder when the vacuum potential changes?
No, it's more profound than that. The fluctuating vacuum potential actually acts on the internal structure of Mercury's atoms.
Yep.
Yes. The secondary charge product of the Sun-Mercury system alters the local vacuum density. As Mercury gets closer to the sun, the vacuum density increases, and the subatomic boundaries of every single atom in the planet are slightly compressed.
And as it swings away,
They relax.
the entire planet is physically pulsating on a subatomic level as it orbits.
Yes. Its inertial mass is literally pulsing, increasing, and decreasing slightly with every orbit. And when you calculate the orbital retardation caused by this continuous mass pulsation, factoring in the electrodynamic drag of the fluid, the framework yields exactly 42.98 arcseconds per century.
It perfectly matches the observed precession.
Perfectly. And it does so entirely within a flat 3D Euclidean space. It replaces the macroscopic curvature of space-time with the microscopic pulsation of the planet's mass boundary.
Wow. But if you take away curved space, you also have to take away curved time. Which brings us to Mystery 21, time dilation. We know for an empirical fact that time moves slower for objects moving at high speeds or objects deep in strong gravitational fields.
We've measured it countless times.
We proved it with the Heffel-Keating experiment by flying atomic clocks around the world on airplanes. GPS satellites have to correct for this constantly, or our digital maps would be miles off. If time is an absolute universal parameter, a ticking clock that never changes, why do atomic clocks slow down when they move fast?
Because time does not bend. The physical mechanisms of clocks slow down.
I need you to elaborate on that deeply.
The framework breaks down empirical experiments like the fast ion beam transverse redshift, the famous Ives-Stilwell experiment, and the GPS atomic clocks you mentioned.
Right.
Standard physics says the temporal dimension literally stretches, causing the clock to experience less time. Redefined Mass says that clock retardation is just a highly advanced form of applied electrodynamics.
Okay, how so? What is happening to the atomic clock?
We have to look at how an atomic clock actually measures time. It doesn't have gears. It counts the orbital transition energy of electrons jumping back and forth between quantum states in an atom, usually cesium or rubidium.
It measures the frequency of the light emitted by those jumps.
Right. It counts the flashes of light. Now, when you place that atomic clock in a dense gravitational field, or when you accelerate it to extremely high velocities in orbit, you are pushing it through a denser fluid.
You are increasing the local dielectric permittivity of the surrounding vacuum.
Yes, the vacuum gets thicker and harder to move through. This thickened, highly polarized vacuum physically compresses the subquantum boundary of the atoms inside the clock.
And what happens when the boundary is compressed?
Because the boundary is compressed, the internal electrostatic fields are constrained. This physical constraint suppresses the orbital transition energy.
Meaning the electrons literally take longer to make their quantum leaps.
Yes, they are fighting through a denser, highly polarized vacuum medium. The frequency of the flashes drops.
Okay, let's anchor this. It's like trying to swing a pendulum. If I have a grandfather clock in my living room, the pendulum swings back and forth at a very specific speed, 1 second per swing. But if I take that entire grandfather clock and throw it into a swimming pool, the pendulum is going to swing much, much slower because it's fighting the resistance of the water.
That is an absolutely perfect analogy.
Time itself didn't slow down in the swimming pool. The universe's clock kept ticking. The physical mechanism of the grandfather clock just experienced more fluid drag.
That is exactly what happens on a quantum level. The cesium atoms in a GPS satellite or the ions in a fast-moving particle beam are swinging their internal pendulums underwater.
So simple.
The universal parameter of time didn't change one iota. The electrodynamic clock was simply retarded by the increased vacuum permittivity.
So all of relativistic time dilation is just mechanical drag on the measuring device. Okay, let's take a breath. We have redefined mass as an electromagnetic bubble.
We've covered a lot.
We've explained inertia as magnetic drag. We've solved the nuclear forces with overlapping fields, turned the sun into a resonating pressure valve, explained gravity without curved space, and proved time dilation is just clocks running slow in a dense fluid. We are going to bring all this together for Part 5, the final mystery we are going to cover today, Mystery 22, Deep Time and the INTCL radiocarbon offsets.
This is where the framework leaves the realm of theoretical physics and completely upends our understanding of human history and geology.
If time is absolute, but physical processes like atoms decaying slow down under vacuum pressure, what does this mean for radiometric dating?
It means we might need to rewrite the history books. This section focuses on carbon-14 dating, which archaeologists, paleontologists, and geologists use to determine the age of ancient artifacts, fossils, and geological strata.
Okay.
The entire field of radiometric dating relies on a single foundational axiomatic assumption, that the radioactive decay constant lambda is immutable.
It's a constant. We are taught that an atom of carbon-14 has a half-life of 5,730 years, and that never ever changes, no matter if you boil it, freeze it, or shoot it into space.
That is the standard assumption. But under postulates XV and XSIC of the Redefined Mass framework, that assumption is fundamentally flawed because it assumes the atom is isolated from the vacuum.
And we know nothing is isolated from the vacuum.
Exactly. In this fluid model, radioactive decay is not a spontaneous, completely random internal event. It is a deterministic process triggered by external vacuum fluctuations, what the authors mathematically describe as rogue waves in the BEC superfluid.
Wait, an atom decays because it gets physically hit by a rogue wave in the vacuum?
Yes. These extreme statistical anomalies in the subquantum fluid bombard the subatomic boundaries of the unstable nucleus. When a rogue wave hits a boundary with enough force, it shatters the containment, triggering the beta decay.
Wow.
And because decay depends on these external vacuum waves, the decay rate is heavily mediated by the local vacuum polarization pressure.
Because a thicker fluid will have different wave dynamics than a thin fluid.
Exactly. The authors introduce a mathematical tool called the dynamic decay tensor. They prove that the decay constant lambda is not constant at all. It scales dynamically with the local solar electrogravitational vacuum potential.
You're talking about the vacuum compressing atoms like the GPS clocks. Does that mean the archaeological clock on Earth has actually sped up and slowed down over time?
It actively has accelerated and decelerated over millennia, depending on Earth's position and the sun's activity. And the brilliant part is, we already have the proof staring at us in the INTCL calibration curves.
What is INTCL?
INTCL is the International Radiocarbon Calibration Curve.
Archaeologists know that raw carbon-14 dates don't match up with other records like tree rings or ice cores, so they use this massive database to correct the dates.
Direct them how?
Well, when archaeologists measure artifacts from the last glacial maximum, the peak of the Ice Age, roughly 20,000 years ago, empirical data shows the radiocarbon ages are often offset. The artifacts appear about 3,500 years too young compared to where they should be in the geological strata.
And how does standard science explain this massive discrepancy?
Standard science assumes it must be due to unexplained, massive fluctuations in the Earth's atmosphere, changing how much carbon-14 was produced by cosmic rays. It's a localized atmospheric guess.
So what does the redefined mass framework say actually happened 20,000 years ago?
It looks at the Milankovitch cycles. These are well-documented historical shifts in the Earth's orbital eccentricity and tilt over tens of thousands of years.
Okay, the Earth's orbit changed.
During the last glacial maximum, the Earth's orbit placed it in a regime of lower average solar insolation. It was physically further from the Sun's dense electrogravitational center for longer periods. Therefore, the Earth was experiencing a relaxed vacuum potential.
The vacuum fluid surrounding the Earth was less dense.
Yes. Because the vacuum was relaxed, the nucleon boundaries of the carbon-14 atoms relaxed. And more importantly, the rate and intensity of rogue wave bombardment in the fluid decreased.
Less waves.
The baseline decay rate literally slowed down.
So the atoms were just sitting there, taking longer to decay because the fluid was calmer.
Exactly. Artifacts from this era retained more carbon-14 than classical physics predicts they should have. They didn't decay as fast.
That makes perfect sense.
So when a modern archaeologist digs up that bone today and runs it through a mass spectrometer, assuming a constant half-life, the artifact exhibits an artificial youth. It looks 3,500 years younger because the clock was literally ticking slower 20,000 years ago.
That is staggering. And the papers also mention the exact opposite phenomenon happening during something called the Lachamp excursion.
The Lachamp geomagnetic excursion occurred about 41,000 years ago. During this event, the Earth's protective magnetic field essentially collapsed for roughly 1,000 years. The magnetic shield dropped.
Which means the Earth was exposed.
Completely exposed. Without the magnetic shield, the terrestrial vacuum environment was flooded with intense solar quantum turbulence. The vacuum was churning.
Rogue waves everywhere.
There was a massive increase in the amplitude and frequency of rogue wave bombardment against the atoms.
The pendulum was swinging in a hurricane.
A perfect way to put it. This immense turbulence fast-forwarded the decay environment. Atoms were bombarded and shattered at an incredibly accelerated rate. Carbon-14 decayed much faster than the modern baseline rate.
So what happens when we date those?
Artifacts from this specific era appear artificially older because so much of the carbon is gone. This creates these massive, jagged dating spikes of phantom age in the geological record that have confused geologists for decades.
The history of our planet is literally warped by the fluid dynamics of space. So what is the ultimate implication of this? If the decay tensor is dynamic, what do we do with our history books?
The implication is that the entire foundation of geological, paleontological, and archaeological chronology must be systematically recalibrated. We cannot blindly trust the constant lambda.
We have to fix the math.
The authors explicitly call for future INTCL calibration curves to abandon the constant half-life and incorporate this dynamic decay tensor. We have to utilize astronomical records of past orbital eccentricities, solar cycles, and paleomagnetic intensity to calculate the exact historical flow of electrodynamic time.
We have to calibrate human history using astronomy and fluid dynamics.
Yeah.
We can't just read the rocks. We have to know what the weather in the vacuum was doing when the rocks were buried.
Exactly. The local vacuum weather dictates the flow of time.
We have covered an immense, almost overwhelming amount of ground today. Let's try to synthesize this monumental shift in perspective.
Sounds good.
We have explored the first 22 mysteries of modern physics through this new lens. We started with the electron's 100-year-old 43 anomaly, discovering the squished heaviside ellipsoid. We found the true electrodynamic origin of E equals mc squared.
Without curved spacetime.
We watched protons swell up in the EMC effect. We guided a fluid wave through the double slits by treating a detector like an open drain in a pool. We solved the blazing heat of the solar corona, replaced the curvature of Mercury's orbit with subatomic pulsation, proved that time dilation is just mechanical drag on a clock. And finally, we watched the shifting sands of radiocarbon dating accelerate and decelerate with the vacuum weather.
It's a completely unified theory.
And every single one of these paradoxes was solved by doing one thing: stripping away the abstract geometry of space-time.
Every single retrodiction is elegantly resolved by treating space as a flat, three-dimensional void filled with a highly active, polarizable Bose-Einstein condensate superfluid.
It's just so cohesive.
The universe does not operate on magical probabilities or bending nothingness. It operates on strict, deterministic, electrodynamic principles.
I want to weave this back to the listener because we've talked about a lot of abstract concepts in deep time. Beyond just knowing how the universe works for the sake of trivia, does this fluid framework actually change anything for us practically?
It does.
Does knowing that mass is frozen light in a superfluid change our future?
It changes absolutely everything on the technological horizon. Think about standard physics. If you accept the geometric interpretation of spacetime, that gravity is a curved dimension and mass is a solid primitive object, you are bound by its limits.
Right.
We accept that we have to use multi-billion-dollar magnetic cages just to briefly fuse atoms. We accept that if we want to travel through space, we have to strap ourselves to massive chemical rockets, ejecting thousands of tons of explosive propellant out the back just to inch forward.
We are limited because we think the stage is unchangeable.
But the redefined mass framework shatters those limits.
Because if mass is just an electromagnetic construct, a bubble maintained by field pressure, we can engineer the bubble.
Precisely. We're no longer limited to just moving mass around. We can manipulate the vacuum that dictates the mass. By subjecting fundamental matter to high-intensity, coherent, phase-synchronized electromagnetic fields, we can actively polarize the surrounding vacuum fluid on demand.
Which leads to what?
The authors explicitly detail the mathematical and engineering foundations for what they call pointing thrusters.
Pointing thrusters? That sounds like something straight out of a science fiction novel. What does a pointing thruster actually do?
It is the realization of true reactionless drive technology. By using asymmetric electromagnetic resonators, we can engineer a local gradient in the vacuum. We can generate a highly directional pointing vector momentum flux.
Okay, plain English.
Because momentum must be conserved globally in the fluid, this directed field generates a real, physical, reactionless thrust.
Wait, it generates thrust without exhaust. What is it pushing against?
It is pushing directly against the polarized virtual pairs of the subquantum superfluid vacuum itself.
It's a propeller that pushes against the friction of empty space.
Exactly. Just like a submarine propeller pushes against the water, a pointing thruster uses electromagnetic resonance to paddle against the BEC fluid of the universe.
That's incredible.
You completely eliminate the need for heavy, volatile chemical propellant mass. You don't need a fuel tank the size of a skyscraper. It provides a viable, mathematically sound, near-term pathway for continuous, long-range interstellar travel. We are looking at the blueprints to the control panel of the universe.
That is just staggering to think that the exact same fluid dynamic principles that squeeze a tiny electron to keep it from exploding could one day be engineered to push a starship across the galaxy.
It is the ultimate unification of the microscopic and the macroscopic.
Yeah.
The rules are exactly the same at every scale.
I want to leave you, the listener, with a final provocative thought to mull over as you go about your day. We started this deep dive talking about the solid geometry of reality that we find so comforting, the device in your hand. But if the redefined mass framework is correct, then the absolute nature of reality is far more beautiful and far more connected than we ever imagined. The matter making up your body, the blood pumping through your veins, the phone you are holding, the dirt beneath your feet, and the stars shining billions of light years above us, they are all the exact same thing.
Frozen light.
They are all just frozen light. They are nothing but localized, vibrating whirlpools of energy suspended in a vast, contiguous, cosmic superfluid.
We are not separate from the vacuum. We are made of it.
Exactly. The universe isn't a collection of solid, isolated objects sitting on an empty, bending stage. It is a single, continuous ocean of tensioned energy. So the next time you pick up a heavy rock or a cup of coffee and you feel its weight pressing down into your palm, ask yourself, are you actually feeling solid matter, or are you just feeling the resistance of the vacuum?